Welcome to a 2014 Avago technical presentation on using our optical isolation amplifiers in solar power systems. Today we will discuss how you can make isolated measurements of voltage, current, and temperature with our optically isolated isoamps. We will first briefly talk about the types of photovoltaic or PV inverter types based on their power ratings. Then specific applications with circuit examples will be shown. The benefits of our optical isolation amplifiers, or isoamps, will be examined. An overview of the entire isoamp family will show you the depth and breadth of our offering. Many design tools, such as evaluation boards and SPICE models, will speed your design process. Our worldwide technical response centers can also assist in amplifier selection and design. Let's now look at a solar power system and its general needs. A PV system uses solar panels connected in arrays and arranged in strings. The string current is collected and combined and then fed to a power inverter. We can segment and describe PV power systems based on their power rating: high power, medium power, low power, and even micro power. In the inverters and string combiners, voltage, current, and temperature sensors are required to have safety isolation. In addition, they must make accurate system measurements. Here is a simplified block diagram of a PV power system. Panels generate DC current, and they are arranged in arrays and strings. The string combiner combines the different current branches. In the string combiner, isoamp current sensors measure branch current, and an isoamp voltage sensor measures the bus voltage of the DC to AC inverter. The DC to DC converter stage boosts the DC voltage to a higher level before being fed to the DC to AC inverter. In these two stages, gate drive optocouplers are used to drive IGBTs and protect them through fault sensing. Isoamps also monitor the DC to AC inverter output current and voltage. In addition, digital optocouplers interface the system DSP controller to a field bus communication link. As you can see, isolation devices are a key element in PV system operation that also add to the PV system's safety and reliability. A complete solution is available from Avago. Since you may be unfamiliar with Avago's isoamp technology, let's have a quick overview. They are easy to understand. First, the isoamp senses the input voltage, an analog signal, and converts it to a digital bit stream or pulse train. Then the digital representation of the input signal is transmitted optically using an LED across the optically transparent dielectric isolation coupling. The LED-based optical coupling pair establishes a signal path while maintaining the isolation barrier. Since the signal is now encoded as a light beam instead of electricity, it is immune to magnetic or other electrical noise. The detector recovers the signal and reconstructs the analog signal through a post filter. Avago isoamps are offered in many package styles: the traditional DIP-8 with surface mount and through-hole options, a compact SO16, and the new stretched SO8 package. The stretched SO8 package is 30% smaller than the DIP-8 version. Avago has an active design program geared to bringing new products to the solar energy market. The ACPL-C87B, C87A, and C870 series of voltage sensors are but one example. Key features of this series include an input voltage range of 0 volts to 2 volts. This is a 10 times improvement over our earlier HCPL-7840 devices. The larger input range improves the signal-to-noise ratio. The second key improvement is the very high input impedance of 1 gigaohm. This is a 2,000 times improvement over the 500 kiloohm specification of the HCPL-7840 series. High input impedance minimizes loading errors. Finally, the ACPL-C87 isoamp series offers 3 gain accuracy options. The C87B has a high 0.5% gain accuracy. The C87A features 1% gain accuracy, and the C870 3% gain accuracy. You can choose a device that meets your design and cost objectives. All the devices are pin compatible and in a compact stretched SO8 package. All devices also meet reinforced optical insulation standards. The first generation HCPL-7840 isolation amplifiers have been well received by you, the design community. Your feedback has led us to make new products with even better specifications. Our new ACPL-C87X isolation amplifiers offer better performance in a smaller package. Blue fonts indicate improved specifications, such as wider temperature operation, much higher input impedance for reduced loading error, wider input voltage range, better gain error over temperature 2, and a more compact SS08 package that meets more stringent safety approvals. The smaller SS08 package gives a PCB area savings of around 30%, but it also features a higher working insulation voltage, 1,414 volts peak, compared to the DIP-8 rating of only 891 volts peak. In addition, isolation voltage per UL1577 is 5,000 volts RMS. Let's now look at some actual circuits for your solar power system. It is straightforward to add isolated DC voltage sensing to your system with the ACPL-C87X series. The DC high voltage is attenuated to 0 volts to 2 volts by a resistive divider. The ACPL-C87X differential outputs connect to a post amplifier for a conversion to a single-ended signal. The operational amplifier also acts as a low-pass filter to reduce noise. This circuit shows DC bus voltage sensing in a typical PV inverter. Adjust the resistive divider ratio, R1 over R2, to scale the line voltage to the ACPL-87X's 0 to 2 volt linear input range. The post amplifier converts the differential output to single-ended output and also forms a low-pass filter. This application circuit uses the ACPL-C87X for 440 volt AC voltage sensing. AC voltage sensing is needed at the PV system's inverter outputs and for grid voltage sensing. In this circuit, a reference voltage, Vref, operational amplifier, and the RF-R1 ratio sets the input voltage range of the isoamp. The output amplifier performs differential to single-ended conversion, scaling, and noise filtering. This shunt-based current sensing method uses a precision, high-power, low-ohmic value resistor to convert current, DC or AC, to a small voltage. The resulting voltage is sensed by the isolation amplifier and reproduced across the optical isolation barrier. Isolation amplifier opticouplers give safe insulation, better temperature drift versus traditional Hall effect current transducers, and are suitable for SMT automated assembly, which helps save space and cost. Here we highlight the very popular ACPL-C79X current sensor series. Key features include 0.5% gain accuracy with the ACPL-C79B part, 60 dB signal-to-noise ratio, a 200 kHz signal bandwidth, and of course, reinforced isolation that meets worldwide safety standards. The SMD package is suitable for automated PCB assembly. Among the many improved specifications Avago has focused on, this is one of the key features you will like. It takes only 1.6 microseconds before the isoamp output reacts to a step input signal. At the 90 to 90% point, the delay is only 2.6 microseconds. This is a critical specification, as the sensor needs to be fast enough to track overload and short-circuit surge current conditions in motor drives and power inverters to eliminate IGBT or power MOSFET damage. IGBT modules are expensive and a key component in PV inverter systems. One method to protect IGBTs is with isolated temperature sensing. Many IGBT modules come with a built-in NTC thermistor. This feature can be used to implement an over-temperature detection function with an Avago isoamp. In the example here, the Avago ACPL-870 features reinforced insulation to comply with safety standards such as EN 61800-5-1. Another area that requires isolated temperature monitoring is motor control. Safety regulations such as IEC 60664 require double or reinforced insulation between live parts of the motor and thermistor temperature sensor. Connecting the ACPL-C87X to build a temperature sensing circuit is very similar to the voltage sensing circuits we discussed earlier. A thermistor is sensitive to temperature, and it changes resistance when temperature changes. In this circuit, we use the 5-volt floating power supply to bias the thermistor. When temperature changes, the thermistor resistance changes, and so does the current flowing through the resistor R2. This causes a change to the ACPL-87X's input voltage. The temperature change information is sensed and transmitted across the optical isolation barrier. Besides the parts we spoke of today, Avago offers many other products. Here is the complete Avago isolation amplifier family. There are both analog output and digital output types. Digital isolation amplifiers have both internal clock and external clock versions. Pick one to suit your design. Start your solution search at our ISOAMP selection webpage, shown here. To quickly evaluate the new ACPL-C87X voltage sensors, an evaluation board has been made and is available along with a user guide. It's available by contacting your local Avago sales representative or distributor. In addition, SPICE models can be downloaded from the Avago website. To evaluate the ACPL-C79X current sensor, there are two types of evaluation boards available. The version on the left is the normal type, and the one on the right is a small module with a shunt resistor and an isolated DC-to-DC power supply module. This module is compatible with LTS series Hall effect current transducers. You can quickly evaluate optical current sensors with this option. You have learned a lot about our ISOAMP current and voltage sensors that are built on our proven optical isolation technology. Avago's new voltage sensor, the ACPL-C87X, features 0.5% accuracy and 1 gigaohm input impedance. Accuracy is 10 times better and input impedance 2,000 times better than our earlier products. Our new ACPL-C79X current sensor features fast response, low temperature drift, and high accuracy. All are ideal for your next solar power system design. You can get assistance on part selection and your design through our worldwide technical support centers. Visit the webpage shown here. Thanks for learning about Avago's isolation amplifier technology and products. For additional information and ISOAMP samples, visit the Avago webpage shown here.